Hello and welcome. Today we're going to be going to do a basic video just doing some examples of finding matrix inverses. All right, so if you haven't already, go and visit the previous video on some of the introduction to matrix inverses, the theory behind it and what it works. But let's quickly review that right here. Okay, remember A is some matrix and it's a square matrix. So it's n by n. Okay, all right, and the question is, does it have an inverse or not? And the idea is that if A has an inverse, then well, A inverse, this matrix, is also an n by n matrix, and A inverse times A is equal to I, the identity matrix. All right. And also, it should also be noted that A times A inverse, right? So we swap the order of the multiplication. That also equals I. And this, we can conclude from this, another point is that basically the inverse of an inverse is the original matrix. Okay, and that of course works out perfectly there. All right, so the question then is, let's talk a bit more about some of the details here. So one fact we have is that A has an inverse if A is row equivalent to the identity matrix. So what does row equivalent mean? Row equivalent means row operations. Row operations to reduce row echelon form lead to the identity matrix. So basically, RREF, the operations to reduce row echelon form of A will equal I. All right, so when that is true, then A inverse exists. Okay, so now the question is, okay, let's find it. So from the previous video, we saw there was a really nice trick. The trick was, first what we do is we take A and then augment it with the identity matrix, and then reduce row echelon form of A, and then if you do enough row operations so that I then reduces to, or sorry, A reduces to the identity, then over on the other side, that right-hand side of the augmented matrix, will lie our A inverse. All right, so I should maybe just make, that is our technique for finding an inverse. All right, so let's do that for an example. All right, so let's do this example. I'm going to talk about a really simple example. We're going to talk about 1 and negative 1. So this is my A, and then 2, 1. Okay. All right, so let's now put it into reduced row echelon form. So what we're going to do, of course, is start with that augmented procedure. We're going to 1, negative 1, 2, 1. And we put the identity on the other side. The first thing we're going to do, of course, is take row 1 plus row 2 and make that the new row 2. All right, and then 1, 2, 1, 0. We add a 1 down there, right? 0 adds to there, get 1 again. 1 plus negative 1 equals 0 by design. And then finally, 1 and 2, that becomes a 3. Okay, good. All right, the next thing we want to do now is we need to now, what I'm going to do, the next row operation I'm going to do is take row 2 and then divide by 3, and that's going to be my new row 2. So I put my little similarity symbol, which says that I'm doing these row operations, and it preserves the solution space or the solution to any linear system that this may have. So what we're going to do that is now that'll be a 1, 2, a 1, and a 0. The top row stays exactly the same. Put my dotted line there. I'm going to put my dotted line there just to help organize my work. And that becomes a 0 still, and this becomes a 1 as we want. That'll become a 1/3, and that'll become a 1/3. All right, the next thing we want to do then, do another similarity transformation. I'm going to multiply -2 times row 2, add that to row 1, and that'll be my new row 1. Okay, 1, 1, 0, 1/3, and then 1/3. Those are all the numbers that are going to stay the same. The number that's going to go away is, of course, this one right there, by design, because I'm going to add -2 of this to 2. That's going to give me a 0, and that's what we wanted. And this will become then, now we have to do a little arithmetic off to the side. I'm going to take -2/3 and subtract it from, add it to 3/3, which is going to give me positive 1/3. All right, so that'll give me positive 1/3. And then finally here, I'm going to take -2 of these and add that to 0 when I'm going to get a -2/3. All right, so here, of course, we have the identity matrix. Then here, that is going to be then A inverse. So I'm going to write that over here. A inverse is going to be 1/3, 1/3, -2/3, 1/3. Okay, we see there's a common factor of 1/3. I can actually pull that out front because remember, matrices, we can always scale or multiply by a matrix. We've defined that type of mathematical operation. So there we go. So now the question is, let's actually, let's just check to make sure A inverse times A does actually equal the identity. There's a 1/3 there, 1, -2, 1, 1, and we're going to multiply by 1, -1, 2, 1. Okay, we take the first column here, we multiply it by the first row of the left matrix, and we're going to get what out of it? We're going to see a positive 1 and a positive 2, so we're going to get a 3. Okay, good. Now we're going to take that first column, multiply it by the second row, and that's going to give us the lower left number. We see that's 0. All right, and the next thing we have to remember here, that we have a 1/3 multiplying by everything, so I'm going to put that 1/3 out front there as well. And then finally, go to the second column, right here, 2, and then we have -2, 0, and then finally we have a 3. Now we distribute in that 1/3, and we get 1, 1, and then zeros on the off diagonal, and that of course is equal to I. Check and done. This does in fact work. So you can leave it to yourself now. I'll let you do this one on your own. Compute that. I contend that it will also equal I. Okay, so you can check on your own for that one. All right, so what I'm going to talk about now is, okay, so we've learned it. We find A inverse via row operations. But there's another way. For 2x2 matrices, there's a shortcut. And this only works for 2x2 matrices. And it's something you might want to put in your mind there, because it's a really easy trick. Okay, A is going to be, I'm going to give you it's just going to be A, B, C, D. All right, and here's the trick. The shortcut is A inverse is equal to, we take the matrix, this is the shortcut. And what we're going to do is we're going to swap the diagonal. So the first trick is to swap the diagonal entries. Okay, the second thing to do is negate off diagonal. Okay, so what we're going to do is now that'll be -C, that'll be -B. And the third thing to do is divide by AD minus BC. Okay, so what we're going to do there is do this. AD minus BC. And there's one thing we need to be clear here. It can't equal 0, obviously. This thing has to be a non-zero number. Otherwise, A inverse doesn't exist. And we'll see later that this computation has a special name. But for right now, we'll just remember that this is the shortcut formula. And that only works for 2 by 2 matrices. Okay, so we can just check this symbolically that this works. So if I go A times A inverse, of course I can always put the 1 over AD minus BC out front, and then we have an A, B, C, D, that's A, and then we have a D and a minus C and a minus B, and what we see there is A, D minus B, C. We can compute the off diagonal. The diagonals you'll see are always going to be, it's always going to be A times D minus B times C. And this diagonal also be A times D minus B times C. And the off diagonals will always be 0. And of course, you clearly see that that is equal to the identity matrix once we distribute this in to those 3 parts. So that's an example of how we can simplify our thing. So if we're going to go back to our original problem that we did on the previous page, let's see if we can do this. A inverse, I said, was going to be equal to AD minus BC, so 1 minus 2 minus a minus 2, which is going to be 1/3. Okay, so that's this part of the thing. And then what we're going to do is we're going to swap the diagonals. So 1 and 1 are the same, so we're just, there's no change in the swap there. We'll put and then we're going to, and then what we're going to do is negate. All right, and of course that's exactly the inverse we had before, that you saw before. So we see that it does actually work. All right, so next now we're going to do, we're just going to do, to finish off our video here, now we're going to do a 3 by 3 matrix, and we're going to use the RREF trick. Okay, so here's a matrix, and it's going to be 1, 0, 0 in the top row. Second row is 1, 1, -1, and finally -2, 0, and then finally a 3. And now what I'm going to do, I'm going to just give myself a little room. I'm just going to start straight away and augment this by I, like that. And now my identity matrix has a diagonal of 3 1s, and then 3 0s on the off diagonals, forming the 2 corners. All right, so the first thing we're going to do is do 2 row operations. I'm going to subtract row 1 from row 2. And that's going to be my new row 2. And I'm also going to add 2 row 1s to row 3. And that's going to be my new row 3. All right, and that's to get zeros here and here. So 1, 0, 0, 1, 0, 0. Nothing changes in our top row. That one is going to be the same. And by design, we get zeros there and there. So now we just have to deal with the rest of it. We see this actually doesn't change because we're multiplying a -1 by a 0 and adding that, so we just get, that'll just stay the same. That'll be 1. And this will be -1 there as well. So nothing changes here. So that's nice. And that's just because, owing to the fact that in this particular case, our matrix had zeros in those 2 columns, the top of those 2 columns. But over here, we'll have to really keep track of things more carefully. We see we're going to multiply by -1 here and then add it to row 2. So that becomes a -1. And then that stays the same, that stays the same. And now here, we're going to multiply by 2 and add. So we're going to put 2 there, a 0 there, and a 1 there. All right, so that, of course, is just recording the row operations that we did here. Okay, so we're pretty close here. You see, the next thing we have to do is we're clearly going to have to divide by 3. So I'm actually going to divide straight away by 3 here. I'm going to just do this. Now I'm going to change my row operation to divide by 3. And so what that's going to do is put a 3 everywhere there. All right, so the next thing I need to do, so this right here, of course, that just becomes 1. All right, so the next thing I need to do now is then add it back up there to zero out that final entry. So what I'm going to do is now take row 3 plus row 2, and that's going to be my new row 2. So 1, 0, 0, 1, 0, 0. Top row is the same, and now I get zeros there, a 0 there, and a 1 there. Nothing changes there. And now there's a 0 there because I'm taking this 1 and I'm adding it to -1. I get 0. And that stays 1 right there. All right, and now here I'm going to add 2/3 to -1. I'm going to have how much left over? I'm going to have -1/3 left over. Right? Nothing changes there. And now I'm going to have a +1/3 there. And now we keep the 2/3 all. The bottom row stays exactly the same, like that. All right, so we see here that this is RREF of A is equal to I, right? Because there's our identity matrix, and that implies then that the thing that's over here, that is A inverse. Okay, remember A inverse is only this thing over here is only going to be A inverse when we row reduce to the identity. So because the row reduction did lead to the identity matrix, this is A inverse. So now, of course, we just have to check. So I want to check. So let's do that here. Should we do a left multiply or a right multiply? I'll just do I'll do a right multiply. So I'm going to put 1, 0, 0. This is my A. So I should say a right multiply of the inverse. So that'll be 1, 0, 0, -1/3, 1, 1/3, and then finally 2/3, 0, and then a 1/3. All right, so let's multiply this up. And it looks like we'll have to put the result down here. Clearly we see we have a 1 in the first thing. We're just multiplying there. And now I go to the second row, first column of inverse, and the second row of the thing. We see we have a 1, -1/3, and then a -2/3. Well, that will make 0 because you're adding +2/3 and then minusing 2/3, so we get 0. Go down here. We get a -2 and then a +2. Add those together, you get 0. All right, so that was the second row, first column of the inverse. So that leads to that corner there. Now we go to the second column of the inverse. We multiply that by the 3 rows and then sum. Get a 0 there, a 1 there, and a 0 there. And finally, the last column of the inverse, we multiply 0 there, a +1/3, -1/3, we get a 0. And then finally, 3 times 1/3 is, of course, 1. That is equal to the identity. So check, it does in fact work. Our matrix inversion was successful. We did all of our steps right. So I hope this gives you some good examples of the technique and getting practice with the basic technique of finding an inverse, and we've learned a few different procedures to do so. So hopefully that helps. Thank you very much.